So what is current? Current is the flow of electrical charge carriers like electrons. Current flows from negative to positive points. Current is also the ratio of voltage to the resistance that is being provided through which the voltage is flowing. If we take current as I, voltage as V and the resistance as R, current I is given as voltage V divided by resistance R. So I is equal to V upon R. The mathematical definition is 1 ampere of current is defined as 1 coulomb of electrical charge moving past a unique point in a second. So what is the potential difference? It is a difference of electrical potential between 2 points. One is a plus point and another is a minus point. From figure, if we take a 12-volt battery, high potential is on the plus side and low potential is on the minus side. So the total potential difference between these uh, 2 points is the potential difference of the circuit. Definition will be given as it is the work done in moving a unit of positive electric charge from one point to another. Means work that is done by moving plus 1 from the positive charge to the negative charge of the battery. What does Ohm's law state? It states that the current through a conductor between 2 points is directly proportional to potential difference or voltage across the 2 points. So mathematically it is I is directly proportional to V. So the current through the conductor is I and the potential difference is V. So I is directly proportional to V. So what does this imply? It implies that the circuit has very minimal resistance, or in very rare case there is no resistance in the circuit. What is power? Power, general statement is power is work done upon time. What is electric power? Electric power is rate per unit time at which electrical energy is transferred by an electric circuit. SI unit is watt, 1 joule per second. Electric power, it is usually associated by electric generators, but it can be also supplied by sources such as electrical batteries. As we can see from the figure, presentation, equation will be given as power is equal to W upon T. W is work done, T is the time required for transferring the energy from one point to another. Unit of power is in watts, unit of work is in joules. Delta E is energy transferred in joules, T is time in seconds. What is energy? Energy is the ability to do work, means the strength and vitality required for sustained work, especially to provide light, heat, or energy for machines. There are many forms of energy, as we know: heat, light, motion, electrical, chemical, gravitational. Energy we can group into different types as a potential or stored energy and a kinetic or working energy. We also know that energy can be converted from one source to another. Basically, there are two categories of energy. One is a renewable energy and another is a non-renewable energy source. Non-renewable energy sources, examples we know like petrol, wood, these are non-renewable. So what is non-renewable is once we burn any form of energy source, it cannot be reproduced again or um, replenished again in a very short time. That is If we consume a particular quantity of non-renewable source of energy in a fixed time, that same quantity cannot be regenerated or replenished in the environment again in a very short time. So these sources can be depleted very fast if we are using them uncontrollably. On the other hand, nowadays, as we know, talk is going on everywhere in all over the world about renewable energy sources. What are renewable energy sources? These are the sources which give energy continuously daily, and there is no end to the amount of energy that we can generate from these sources. Examples, as you can see in the figure, solar energy, wind energy. These are two primary sources of energy which can be accessed very easily, and nowadays they are being accessed very easily and on a very large scale. One more source of renewable energy sources is very few people might know is the tidal wave energy. Tidal wave energy we generate with the help of the waves that are in motion in the sea. These renewable energy sources can be used to produce heat, electricity, and hydrogen, which can be consumed in later stages as required by the industry or the public. What is a magnetic circuit? Magnetic circuit is made up of one or more closed loop paths containing a magnetic flux. This flux is usually generated by permanent magnets or electromagnets. It is confined to the path by magnetic cores consisting of magnetic materials like iron. There may be air gaps or any other materials present in the path. From figure we can see that the core is made up of iron, and we are connecting external wire having n number of turns. And when this winding is given electric supply, we create a magnetic flux. This flux will flow through the whole core of iron, and this flux will be responsible for creating a magnetic circuit in the iron core. Once we cut off the electric supply, this iron core will lose its magnetism after a particular time interval. So this is how we set up a magnetic circuit. So what is MMF? MMF full form is magnetomotive force. It is the electrical motive force and may be considered the factor that sets up the flux. The magnetomotive force is equivalent to the number of turns of wire carrying an electrical current, and it has units of ampere turns. So magnetomotive force is responsible for setting up the flux in any conductor, and this is called as the magnetomotive force. Now what is a magnetic force? Magnetic force between two moving charges may be described as effect exerted upon either charge by a magnetic field created by the other. From figure we have two magnets. It can be a permanent magnet or it can be a temporary magnet. So when these two moving charges, they are either brought near or taken away, the force that is exerted by these two magnets on each other, that is called as the magnetic force. So this magnetic force, depending upon the poles that are generated in the both magnets, either will have a means repulsion means we will be repelling the two magnets away from each other, or if the poles on those two sides of the magnets which are near to each other, if they are of opposite charge, then they will be attracted to them, called as attraction. So depending upon the magnetic force that is present on the individual magnet, we can have a repulsion charge or we can have a attraction charge.